talking about. Algebraic expressions is chapter 4. Come on. A lot of what we do today, all right, algebraic expressions and formulas, some of it's just going to be order of operations. That's basically punching it in your calculator. We did last chapter, so that's nothing new, okay? Here are the things specifically we're going to look at. Evaluate algebraic expressions, use mathematical models, understand the vocabulary of algebraic expressions, and simplify algebraic expressions, which is basically the order of operations. All right. So what is algebra? Algebra is the point some of y'all decided y'all didn't like math anymore, right? Because it's all going along smoothly in middle school, elementary school, until you got to this point when they started putting letters in there.
Middle school.
And then it's like, what in the world's a letter doing in a math problem? Well, the letters in math are called variables. And basically, anytime you see a letter, they are letting that letter represent a number. We just don't know what the number is. It's a specific number. It's like an empty box. Anything can be put into that box. An algebraic expression, then, is a combination of variables and numbers using the operations of addition, subtraction, multiplication, or division, as well as powers or roots. So there at the bottom there, you can see examples of algebraic expressions, x plus 6. So that's when it went away from being math to algebra, when instead of saying 5 plus 6, it said x plus 6. X squared minus 6, 6x, square root of x plus 7. Notice what's in common with all of those is a variable. And we know variables could be any letter, A through Z. Most often you see X and Y used because that sort of flows with different things as we go along, but it could be, those X's could be replaced with A, they could be replaced with Z, they could be replaced with T. Okay? So we've already talked about order of operations last chapter. I'm not going to go back through that. Please excuse my dear Aunt Sally is the thing I use. All right. Now, the only difference this time to what they did last chapter, as you can see, they're going to ask you to evaluate an algebraic expression. 7 plus 5, parentheses, x minus 4, close parentheses, cubed, for x equals 6. Then all we do, notice what they did, is they replaced the x with what x is equal to. So everywhere I saw an x in this statement, I'm going to replace it with a 6. If it's a negative number you're replacing with, it's very important that if you're using your calculator, you put it on in its own little set of parentheses so you don't get that negative mixed up with a subtraction or something like that. But notice once we put 6 in there, right here, now it's just an order of operations. I can put this directly into one of these calculators I have provided. Either one, the graphing one or the other calculator that you have there. All right, the order of operations, say parentheses, please, excuse my dear Aunt Sally, parentheses first, which means I would do the 6 minus 4 first. That's where they got this 2. Then the excuse is the exponents. They would do 2 to the third. Next, which is 8, as you can see. And then once they get to there, there's a addition and multiplication. Multiplication always goes before addition. So they multiply 5 times 8 to get 40, and then add 7 to get 47. But your calculator will do that. But if you are doing it out by hand, this is the way it steps through. Okay. Here's another one. Now this one has more variables. X squared plus 5x minus 3 is the algebraic expression. And it wants you to evaluate when x is equal to negative 6. Now, this is where it is very important that you put the negative number in parentheses, okay? So notice right here, they replaced the x with negative 6, and they put the parentheses around the negative 6. If you are using your calculator and you do not put parentheses around that negative number, whoops, let me back up here on this one. if I do not put the parentheses around this -6, it's not going to square the negative and it's going to give you a wrong sign to your answer. All right, so make sure I do it whether it's positive or negative. I'll bring some computers in here once we get going. I get through this. Just to stay consistent, but if it's negative, you really do need them. All right, so notice they put the -6 in for the x where it was squared, and then the -6 in by the 5. And then there we go. Please excuse our dinner Aunt Sally. Exponents first, -6 squared is 36. Then we're going to do the multiplication of 5 times -6, which is -30. Then we just have additions and subtractions. You go from left to right. 36 plus a -30 is what? 6 minus 3 is 3. All right. Easy enough. That's really, we don't need to spend much time on that because that was the last chapter. We should have that. And I'm going to go through this one a little quicker. Now, notice here the difference is they give us an x and a y in the algebraic expression. -2x squared plus 5xy minus y cubed. Well, then they tell us x, wherever there's an x, we're going to put in 4. Where there's a y, there's going to be a -2. All right. They don't use parentheses around the positive numbers. I would suggest go ahead when you put in your calculator to put parentheses around the positive numbers too that you're substituting in, but you don't have to. But notice they put in 4 for x wherever there was an x, and they put in -2 where there was a y, and then they did the order of operations. Okay? So that's what we're talking about when we're talking about evaluating an algebraic expression. Substituting in for the variables they say and give you numbers for, and then using your order of operations to get through it. Okay? Just some terms here. When we're talking about an equation is when it is going to have a math or an algebraic statement, but there is an equal sign between two algebraic expressions. There's an equal sign in there, right? That makes it an equation. A formula is an equation that uses letters to express a relationship between two or more variables. So when we're talking about a formula, we could be talking about like the area of a circle. What's the formula for area of a circle? A equals pi r squared. Or the area of a rectangle, length times width, L times W. That's a formula, which it uses variables, but it is a little bit different than an equation, whereas an equation is what we're usually going to look for to solve. Mathematical modeling, when we talk about that, is the process of finding formulas to describe real world stuff. Anytime you hear modeling, they're talking about trying to bring it into the real world, something that you could run into out in the real world somewhere. Okay. Here's an example of, says modeling caloric needs. So the bar graph shows the estimated number of calories per day needed to maintain energy balance for various gender and age groups for moderately active lifestyles. And then they've got a mathematical model. F equals -66x squared plus 526x plus 1030. They're calling this a mathematical model because they took some research from some active people and came up with this formula. We're not going to talk about how they came up with the equation, but that's it. And pay attention to what it describes. It describes the number of calories needed per day by women in different age groups. So if you notice, you go down to the chart, it has females in red, males in yellow, and then it has different age ranges. Each group 1, 2, 3, 4, and 5 is a different age range. 4 to 8, 9 to 13, you all fit into group 3, 14 to 18. I fit in one of the other ones, group 5, actually, 31 to 50. So, that would be me. Now, here's the question. According to the model, how many calories per day are needed by women between ages of 19 and 30 with this lifestyle? So if we notice 19 to 30 is group 4, and all they wanting us to do now is we found the group 4, and 4 is what gets substituted into X into the model, right? It says per day by women in age group X. That is age group 4. So we're going to substitute 4 in for X. So this is doing exactly what we were just doing, and they just put it into a word problem, made you work a little bit to pull out what you needed to put in. So it's going to be negative 66 times 4 squared plus 526 times 4 plus 1030. You notice there that it says women in the 90 to 30 age range that are moderately active need 2,078 calories per day. Now, if there was somebody that was inactive, you would need fewer calories. Somebody that is extremely active would need more calories, right? That's how it works.
Station father, pardon the interruption. Ian Hillis, report to the office, please. Ian Hillis.
All right, some more vocab terms. So, when we're talking about algebraic expressions, when we talk about a term, and I will use that a lot, term, it's talking about a single expression that is separated by pluses or minuses. For example, 7x minus 9y minus 3 has 3 terms. 7x is a term, negative 9y is a term, and negative 3 is a term, right? They're separated by pluses or minuses. If it is a minus, like minus 9y, I do consider that term negative 9y because that could be written as a plus a negative 9y. So you sort of use the sign that's in front of it to determine whether it's positive or negative. Coefficient. It is very important that you understand when I talk about a coefficient, I am talking about the number that is in front of the variable. So 7 is a coefficient there, and negative 9 is the coefficient of y, right? And we know that if there is no number in front of the variable, it is an understood 1, correct? Anytime you see an x or a y and there's no number immediately in front of it multiplied by it, it is understood to be 1. A constant is the number part that doesn't have a variable. So negative 3 is the constant. Okay, it's a constant because we know what that number is. It doesn't have a variable attached to it that could change. Negative 3 is negative 3. Like terms, when we talk about like terms, they are terms that have the exact same variable part. 7x and 3x are like terms. Up there in that one above, 7x minus 9y, those are not like terms because the variable parts are different, and they have to be exactly the same. If they're at the bottom, if that was 7x squared and 3x, they would not be like terms because it would have to either both be 7x squared and 3x squared, or they would have to both be x's, okay? And factors are parts of each term that are multiplied. 7's a factor of 7x, x is a factor of 7x, okay? And we talked about these properties before. Commutative, doesn't matter what order. Associative, it doesn't matter how you group when they're all addition or they're all multiplication. Distributive is when you take the number on the outside of parentheses and multiply it through. So we're not going to spend a lot of time there because we've already done that. Now, the last part of what we're doing today is simplifying algebraic expressions. Here's the 2 things you have to understand when we say simplify. Simplify means there cannot be any more parentheses with any operations in it. So there can't be a parentheses with an addition or subtraction or multiplication or division, or really addition or subtraction. And then there can't be like terms that have not been combined. So on this particular problem, 5 in parentheses 3x minus 7 minus 6x. The way we get rid of parentheses is you distribute the number that is immediately in front that is multiplied by it. Now, if there's a plus or minus sign between the number and the parentheses, you don't distribute that number. But notice that is 5 times that parentheses. So to get rid of the parentheses, we distribute that 5 to both terms, and that's what they did. Notice they took 5 times 3x, and then they took 5 times negative 7. Once you do that, I don't need the parentheses anymore. Okay? then you actually go ahead and multiply it together. 5 times 3x is 15x. Negative 5 times 7 is negative 35. So I'm going to have 15x minus 35 minus 6x, like they have right here. Okay, now it's still not simplified because I have like terms there that are not combined. Now, if that was 15x minus 35 minus 6y, I could be done. But since that's a 15x and a 6x, I have to combine those, right? And like terms that are added or subtracted, you combine them by adding or subtracting the coefficient, and the variable part stays exactly the same. So 15x minus 6x is going to be 9x. Okay, and it really doesn't matter if the 9x is before the minus 35 or after, but generally we put terms with variables before constants. So we're going to put, no, and there they showing how they grouped it together, 15x minus 6x, and notice they end up with 9x minus 35. That is now simplified. There's no parentheses left. There are no like terms left in the algebraic expression. All right. Let's see if we have another example. Yeah, this one, another example, they went ahead and put it all out. 6 times the parentheses of 2x squared plus 4x plus 10 parentheses 4x squared plus 3x. So we've got to get rid of the parentheses first. Now, if that 6 was not immediately in front of that parentheses, and there is no number immediately in front of the parentheses, you assume it to be a 1, just like it was in front of a variable. And you would distribute through a 1, which basically just drops off the parentheses. But in this case, I've got to take the 6 and distribute it to both the terms. Once the parentheses stops, you stop distributing. So it's going to be 6 times 2x squared and 6 times 4x, which they've demonstrated down here. And then I've got to distribute the 10. Now, if this is a minus, you got to be very careful to make sure you distribute a negative along with it. But it's a positive. So positive 10.
I got you, G.
I'll get it. They can just wait on the video for a second.
Yeah, you know they want me.
Hello? Yes. Okay. Marshawn, Coach Miz real quick.
What
I should have let you answer it. It was for you.
I know where he at.
He's in his office. You know where it is?
Nah.
You know when you go down these steps, start walking to the office? Walking to the office like this, and that's guidance doors. He's right there to the left. There's a little door. You just walk right in there. He's right in there.
Because you know where the stair hallway is? Nah, by cafeteria? Yeah, the one in front of the guy's
Go down the
office.
bottom of these steps.
Okay.
Cafeteria's that way, right? You're gonna go this way.
Can I just show him?
And you see those double doors? There's a door right here before you get to those double doors. Go in it and just.
You want to room them?
I don't know what room number
Can I just show him?
Yeah, take him down there.
Come on.
All right, here we go. Let's finish this up. So I distributed 10, I distributed 6. 6 times 2 is 12. 6 times 4 is 24. That's where we get 12x squared plus 24x. 10 times 4 is 40. 10 times 3 is 30. That's where we get 40x squared plus 30x. Now, we have to combine like terms. Now, that next step there that has the parentheses around it, that can be skipped. There's no reason to me to rewrite all that and put parentheses down. What I can do is I can just look through here and look at terms that are alike. I see a 12x squared and a 40x squared. I know I'm going to add those. 12 plus 40 is 52. That's where they get 52x squared. 24x plus 30x, that's the like terms. 24 plus 30 is 54. So I end up with 52x squared plus 54x. All right. But I would not do this. I wouldn't rewrite all that. And I probably wouldn't rewrite all this either. This just sort of showing you what's happening. I would go from here to the third step to the last step. And that's it. So I will Like I said, the only difference to make sure is if it's a negative right here, make sure you're distributing that negative along with it. So if that was a minus in front of that 10, there was a minus in front of that 10, then that would have been a negative 40x squared minus 30x, because that negative would have got it multiplied along with it. And if it's a minus there and there's no number, then that's like a -1 you distribute, okay? So that's the end of the show. And I'll bring your assignment up. Let me see if I can stop this recording. Hopefully it recorded.